Appreciate the opportunity to be here today to talk to you about woody biomass. Scott was introducing me. I'm the project leader with the Forest Service Research Unit that's here on campus, and our unit has a nationwide scope of work. We get to do projects across the whole country looking at issues associated with the tools used to manage forests, and right now a major topic for forest operations research is related to woody biomass. And as we've looked at research projects associated with that, we're finding that there's this debate about, is woody biomass going to be real or not? Are we actually going to be able to use wood for energy? Is this going to be a part of our future, or is this just a flash in the pan? When I first came here in 1983 from Idaho, pulled up into the parking lot out here at the Forest Sciences Lab, and there was a great big yellow machine sitting out behind it, the NICHOLSON-KOCH mobile chip harvester. And that was one of the Forest Service original forays into woody biomass harvesting in southern forests. Giant machine was designed around the oil crisis in the late 70s, and it was intended to be able to drive through southern forests, chew up everything, turn it into wood chips that we could use for energy. And that machine just kind of went away, along with all the research interests. So people are asking, with woody biomass now, is it real, or is it just going to be another flash in the pan? Okay? This morning, what I'd like to do then would be to review some of these developments about woody biomass utilization for energy. I'm going to talk to you a little bit about some of the operational studies and cost things that we've been looking at recently, and then wrap up with some discussion about the impacts and social issues that people are concerned about as we look at utilization of wood. To begin with, it's really important to understand that from our nation's focus, this is an issue of energy. If you look at all of the legislation that's been developed, the Renewable Fuel Standard and others, they all start out with, this is all about energy independence. And this is something that the government has been harping on for years and years, is we've got to reduce our dependence on foreign sources of energy. So it's about where we get our power, how we're going to use these sources to create the different types of energy we use. In the United States, most of what we use right now is petroleum. Coal, second biggest chunk, then natural gas, nuclear, and renewables are in there. Current use of wood for energy is up in that little green pie slice there. So most of the stuff that we have is coming from petroleum. It's also informative to look at this one, which is where we use these different sources of energy. So for electricity production, that's where most of the coal's going, and that's the biggest chunk of the pie of how we use energy in the United States. We make electricity with it. We make it from coal. When we talk about transportation fuels, the things that drive our economy, the things that allow you to drive your car around or move the goods on the highways or ships or trains or all the other kinds of transport, it's an issue of petroleum use. So most of our transport energy is coming from petroleum. Industrial is dependent on petroleum, but then also a lot on natural gas. So we have a demand for energy. We get it from these different sources. And as I mentioned before, our national issue is dependence on foreign sources. It's energy security, issue number one. And if you look at what we import about half of the oil that we use. Half of the half is coming from the Western Hemisphere, Canada, Mexico, places like that. The one that gets people nervous is the 18% of the half that we import is coming from Persian Gulf areas, places in the world where the President will talk about these are unsettled places, places we aren't sure that we can rely on as sources of oil. So energy security is the driver for our national concern about where we get our energy from. And that leads to the development of things like the Renewable Fuel Standard in the ESA, Energy Independence, again, and Security Act, 2007, set out a goal. The concern is dependence on foreign oil. Let's find some local sources. And so they laid out this goal which says that by 2022, we're going to be getting 30-something billion gallons of fuel from non-petroleum sources. A bunch of that is corn ethanol, which is the orangey bars at the bottom, and then this stuff up here is other types of cellulosic fuels. So looking at wood primarily in there, although other kinds of ag residues like corn stover, etc. Renewable Fuel Standard set out a goal to produce a bunch of fuel from non-ethanol or non-corn sources. Energy independence. Second issue that comes out is related to the impacts of how we use our energy. So the tailpipe emissions, the stuff that comes out of power plants and set her up, the smokestacks, because of the way that we're creating our energy, leads to concern about CO2 in the atmosphere and possibilities of changes in global temperature. And so you get these kind of maps that show, oh my gosh, in the next few years, We could see rises in temperature around the world that are going to change the world as we know it. People are concerned about the environment. And we get to, can polar bears swim or not? Gets them listed on the threatened species list, leading to regulation of CO2. Polar bears can swim, so we don't have to worry about the guy on the ice floe. But the EPA is still going to regulate CO2. And what they're doing right now, there's a power plant draft. It's been delayed over the summer, but it's due this week, September the 30th, is going to be EPA rules regulating CO2 emissions from power plants. Followed in December by a draft rule of performance standards for refineries, with the final rules to be developed by next spring. This is a big driver. Even though our policy statement that led to the renewable fuel standard says it's energy independence, regulation of CO2 is going to drive significant changes in the way we produce power, affecting that coal section of our energy picture. Both the concern about energy independence and environmental impacts are playing out on the international stage as well. And so in Europe, they have a similar sort of drive going on. They have something they call 20/20 by 20, and what they're looking at there is a 20% reduction in their consumption of energy, recognizing that energy efficiency is one way to improve this whole picture. 20% reduction of fossil fuel use with a 20% increase, or having renewables be 20% of their energy portfolio, by the year 2020. They want to have 10% of their transportation energy be coming from renewable sources. And that leads to the member states developing their own legislation and policy directives that are driving increasing use of renewable energy. So, for example, in Germany, they have a Renewable Sources Act, kind of like our RPS and other types of legislation, which says in some parts of it, it's going to say that the electricity grid has to be open to everybody that wants to put electricity there, and power that's produced by folks has to be purchased at these feed-in tariffs. And just as an example down here at the bottom, if you're burning wood for biomass in a facility that's going to be 5 megawatts or more, then you're going to get paid 8.17, whatever it is, cents of a euro per kilowatt hour. If it's coming from wood, then you get this extra 2.5, and if you're doing short rotation woody crops, it's 3.96. But basically, there's a chunk of incentive here for people to be developing these renewable sources of energy that's happening in Europe. And that's leading to this growth that we see of the import market for wood energy to European markets. In the UK, for example, this is a picture of Port Talbot, which is one of the world's largest wood-only power plants, or at least it was at the time of their press releases. 350 megawatts of electrical capacity would be sourced with 3 million bone-dry tons of wood chips that would be coming from the U.S. and Canada. So those kinds of markets are developing in response to the Europeans' concerns about energy independence, about environmental impacts, how they use energy, leading to wood demand in the U.S. So when everybody adds that all up, we look at it and say, gosh, there's all this potential energy use out there. If we take 30% of our U.S. petroleum consumption and say we want to replace that with renewable sources, that adds up to about 1 billion dry tons per year, hence the billion-ton report, which everybody may be familiar with. The Renewable Fuel Standard that says we've got to have 16 billion gallons of cellulosic ethanol by the year 2022. If you look at that one, that'd be about a demand of 200 million dry tons of stuff per year to be able to make all that ethanol. We've got all this European Union demand for pellets, for wood chips, for other forms of renewable material. And then we've got the potential demand from electricity generation if those power plants face regulation over CO2 emissions from the EPA. Depending on how those play out, they go to co-firing with wood, and they'll be adding demand. So these new energy uses could easily be putting a market out there for 300 to 500 million tons per year of wood to feed these different sources of demand. Put that in perspective, 300 to 500 million. If you look at our current roundwood production, and actually we're using a little bit bigger numbers now, so a couple years ago it was 16 billion cubic feet per year in the United States. So we're talking about potentially more than we're doing right now in roundwood production in terms of the opportunities for wood to be used for energy in the future. Wow, that's a lot of wood. So part of this, can we cut it or not question, comes down to, is there enough stuff out there? Do we have wood that we could use for this? And they chartered the billion-ton report, and the new version, the update, is out there. Y'all can download this if you want from the DOE's website. The billion-ton report is premised around the idea that we want to look at the feasibility of replacing 30% of our petroleum use with renewable sources by the year 2025. So it's looking out to about 2025, 2030. Update was just completed. In the newest version of this report, they're looking at a wide variety of sources from forests and ag, and they're thinking that maybe in the United States we've got about 48 million tons per year of logging residues that we could bring in and use for energy production. From forest thinnings, maybe 25 million tons per year. There's some other forest land stuff that is pretty small. They've also looked at bringing in pulpwood supplies as part of this, and energy crops, short rotation woody crops, etc., being played in. Total, when they add it all up, depending on their scenarios that they're looking at, maybe 80 to 120 million dry tons of wood would be available. One of the things that's neat about the new version of the billion-ton report is that they've done it on a cost curve basis. And so the numbers that are available depend on how much the feedstock is selling for. $40 a dry ton, I get this much. At $60 a dry ton, I get more. At $80 a dry ton, I'm going to get even more. And so, for example, on the part here that's showing potential contribution of woody energy crops to this energy picture in the billion-ton report, they show a graph like this. So we've got different years, 2017, 2022, out to 2030. And this is the supply available at $40 a dry ton, $50 a dry ton, $60 a dry ton. The perennial grasses, there's your switchgrass bar, Scott. Woody crops in red, annual energy crops in orange. And so what this is showing is that wood comes into the picture as the price goes up. It's costing a fair amount for stumpage and harvesting, et cetera. So as we get into the higher prices, then more of it's going to come in. 2022, at $50 a dry ton, they're projecting maybe you get 40 million dry tons a year of woody energy crops being produced, compared to 77 million dry tons per year of perennial grasses, switchgrass and other kinds. So the billion-ton update, looking at it on a cost curve basis, wood's coming into the picture, but it comes into the picture when it's more expensive. It's also coming into the picture relatively small amounts, 100, 150 million dry tons per year. Another look at this right now that's just being completed is the Southern Forest Futures Project. In the Southern Forest Futures Project, we're looking at what's going to happen in our southern forests out to the year 2050 under a range of alternative scenarios for the future. So they're looking at things like population growth is extreme versus population growth is moderate. They're looking at energy prices are high versus energy prices are low. It's a set of different future scenarios. What they're looking at here in Chapter 10, they looked specifically at the development of bioenergy and how that might impact our southern forests. They're suggesting in this one that we might get maybe 50 million green tons per year of biomass from southern forests available for energy by the year 2020. They're looking at the possibility under some of their scenarios that we might have a 40 to 70% increase in harvest volume in the south to provide wood into energy markets. So almost doubling total wood output, 40 to 70%. And to meet that, where's that wood going to come from? Probably from increases in pine plantation. One of the things that the Southern Forest Futures Project looked at is that the most viable energy crop from wood in the southern United States would be loblolly pine, so an increase in pine plantation acres. 39 million at the top end would go up to 67 million acres. So here's an example of one of the graphs from this Southern Forest Futures Project. I'd refer you to that one for more reading if you're interested in this topic. So under the medium consumption scenario, the high consumption scenario, we get this kind of a graph, this kind of a curve here for woody biomass going into energy over time. Out at 2040, mid-40s, they're seeing that under that high consumption scenario, it could be almost as much as our current timber product market would be. That's that doubling of cut out in the year 2040. And back here a little closer in time, maybe 2020, it's looking at about that 50 million tons per year kind of number. So, billion-ton report, saying wood could come into this market in different ways. Southern Forest Futures Project showing that, yep, wood could come into the market different ways, but it's all constrained by cost. And it's constrained by the value of the thing we make from our wood or from our other materials. And if you look at this one, this was actually really good prices in California. I thought it was awful years ago when I took the picture. But just as an example, if I'm going to turn it into a fuel that I'm going to put in my car, conversion rate of about 80 gallons per dry ton. If the refinery's cost for their feedstock is what they're able to pay is $1 a gallon, then that would say the value would be $80 per dry ton. If the refinery could afford to pay $1 a gallon into the stuff that they're making, it would convert to $80 a dry ton. It's interesting, Keyor is a company that is putting in pyrolysis plants in Mississippi right now. Their first one is being constructed. I think it's a 30 million gallon a year kind of facility, something in that range. And then they've got a second one that'll be bigger and a third one that's even bigger than that that's on the books. They're going to create pyrolysis oils from wood chips. And they have agreements where they're going to take that pyrolysis oil, take it to biorefinery where they're going to turn it into transportation fuels, other kinds of liquid energy products. They've stated in their initial stuff that they think they can pay up to $72 per dry ton. If I'm turning it into an electricity product, projects that we've worked on, we're seeing that 1 oven-dry ton of wood will give you about 1 megawatt hour of electricity out of the power plant. Okay? So if your bill, your electric bill, is 7.5 cents a kilowatt hour, that's going to turn into the electricity's value at the end of the day is $75 per ton of wood. Okay. Can they afford to pay $75 per ton? No, they can't pay the logger, the landowner, for all that because they've got to cover all of their operating costs. And so what they have to do is something less than that, maybe 30. Yeah. So the ultimate value of this stuff for energy limits what we can get for it in the field. It presents significant challenges to us for being able to have systems that can produce this material. DOE has done similar kind of analysis, and they've developed this thing they call their multi-year program plan, which is their driver, the target that they put out there. And they're saying that if we're going to have a viable renewable energy industry, renewable fuel industry, that we've got to be able to hit these cost targets to make it all pencil out, to be able to put it into people's tanks at a reasonable price, to be able to have some processing costs, et cetera. And what they have for their targets are by the year in this original multi-year program plan, which has just been revised, by the way, so there might be some new numbers. For their feedstocks, their target would be 39 cents a gallon going into a gallon by the year 2012, 33 cents a gallon by 2017. What that ends up being is that you can only, at an 80 gallon per dry ton yield, you could pay $31.20 for the feedstock cost by 2012, $26.40 per dry ton by 2017, per dry ton. So that means only $13 a green ton to get it there. There's no way we can deliver wood at that kind of price right now. We can't hit DOE's goals at this point in time. So is this even going to be possible? So a couple of key points here out of this background stuff. The driver is energy independence. The number one driver is energy independence. I would make a point here that that driver can be satisfied by hydraulic fracturing of oil shales. The amount of domestic supply of oil is on the rise. And so we are somewhat satisfying our concern about energy independence through development of traditional fossil fuel types of sources. But that driver energy independence is out there. We also have that driver of the environmental impacts, the regulation of CO2 emissions. That one's still significant, still could lead to shift to renewables, significant shift to renewables. So the estimates that we have to satisfy those kinds of concerns are saying that it's hundreds of millions of dry tons per year are needed if it can be available at costs less than $40 a dry ton. I would put a little sidebar down here. This is to remind me that I mentioned that the ultimate value drives what we can pay for it. There's some other activity going on right now recognizing that that limits the value of the feedstock. What about turning it into something that has more value? So there's developments in torrefaction. There's the little HMF thing at the bottom is something called hydroxymethylfurfural. Is there a wood chemist in the room? But hydroxymethylfurfural is something that can be used as a chemical precursor for other sorts of products that are not energy related that may have higher values, and so the feedstock cost could go up if somebody invents a magic process that turns wood into HMF in a good way. So, can we do it? How can we get the technology to do this kind of thing? Well, the reason logging residues show up as the first bite at the apple, if you will, is that we just go out there, the stuff's already at roadside, we're paying for chipping or grinding on logging residues. That's the cheapest way to get wood into an energy product. And if I'm looking at our cost for chipping residues, we're thinking it's about $13 a dry ton, somewhere in a range around there. Maybe it's 10 to 15 or something is the range. Residue chipping is a little less productive than chipping pulpwood, putting whole trees through a chipper or grinder, because I've got scattered limby kind of material and the productivity of that machine suffers. We know that if we go and put it into a larger size, fuelwood chipping or grinding, then we're more productive, costs are lower, and we've seen values in the $6 to $10 a dry ton kind of range for taking small trees, putting them through a chipper or grinder, turning it into an energy product, just for that chipping or grinding function. Okay? And in fact, some of the work that we're doing here in Alabama looks at issues associated with what is the fuel consumption, what's the performance, productivity costs associated with different kinds of chippers and grinders, the feedstock quality that's associated with the stuff that comes out of them. You put that together in a system, and so Dave, maybe this is where you were going with your last question, is that we've been doing some benchmarking on conventional southern thinning for fuel wood types of operations. Right now, the average price for fuel wood chips in the U.S. is somewhere, delivered price is somewhere in the $22 to $24 ton range. Okay, we were looking at southern thinning operation, looking at it operating on a different harvesting unit, so there's variability between the different units. But we're looking at costs for felling, maybe $5 per green ton. I'm switching units, sorry about that. $5 a green ton, $3.50, $5.25. That's the felling side of it. The chipping and putting it in the truck side, $3.30, $2.68, $5, $4.50, $3 something. You end up with a total cost in the truck of $16 to $17 per green ton. And then you've got to haul it somewhere. Okay. So that $22 to $24 a green ton, what people are willing to pay right now for fuel wood, doesn't move the wood very far when the system that's producing it from the thinning is costing $16 to $17 a green ton. But it doesn't include a stumpage payment to the landowner. So how are we going to solve these kinds of problems? We're thinking that to hit that DOE target, we've got to develop more efficient ways of harvesting wood, of moving wood. Our DOE project that y'all may be familiar with, that Auburn University and the Forest Service and Corley Land Services, Tiger Cat are working on, is focusing on that. How efficient can we get at cutting, chipping, moving wood into fuel wood kinds of operations? So a high production, high performance feller buncher coupled with large capacity grapple skidder, going through more efficient chipper and different types of vans and different ways of operating. How low can we get that price? Can we get it down to the levels where we could hit that DOE goal through maximizing efficiency? This is the vision that the Forest Futures Project has in mind, is that if wood for energy is going to develop in the southern forests, it's going to be pine plantations. A big chunk of it's going to be pine plantations that are harvested in very efficient ways, not ways that we're doing it today. Better price structure than what we have today. There's other types of biomass harvesting operations going on that are clearly not cost effective, but they're part of forest management in the South, forest management in other areas as well. An example, project that we did in Kentucky. If there was a market for wood for energy and we could take biomass out of the forest, how much is it going to cost us doing it in central hardwood kinds of operations? And I put this one up here as an example of how far away from the mark we actually are in some of these places. So this one was looking at different kinds of silvicultural prescriptions in an upland hardwood forest, from shelter wood through a thinning. In the shelter wood, they were taking out 77 tons per acre, about 70% of the basal area. It was 50-50 biomass and saw logs, and let's just assume that their harvesting cost was 100%, okay? If I go all the way down here to the thinning, where I'm doing a silvicultural treatment, but I'm not taking very much material out of the woods, and all I'm trying to take out is the biomass, then taking out 32%, about a third of the basal area, most of it's biomass, I add 50% to my costs. Right? Well, as an example, in this particular study, the contractor we were looking at, the kinds of operating methods that they had, etc., that harvesting cost was about $100 a dry ton. So down here, get biomass out of the woods, that's $150 a dry ton. There's no way that's cost competitive in any kind of energy market. So harvesting biomass can be very expensive. It might be used as a management tool, but it's not going to make anybody money by taking biomass out of upland hardwood kinds of treatments in the fashion that they did here. Another thing that we've looked at in southern forests would be harvesting understory. And this particular machine is a pull-behind combination mulcher baler. This is working in a pine plantation in South Georgia in this particular picture here. And they're doing this treatment in lieu of other types of understory clearing, removal sorts of things, fire or herbicide or something else. So you put this machine in, it mows through, cuts the stuff down, chops it all up into pieces, rolls it up into a bale, and we could bale that and take it out to roadside, take the bales out to roadside for about $50 a dry ton. And this is what you get out at roadside are these bales. They weigh about 1,000 pounds apiece, all rolled up nice and neat, can go on a truck, go off to the facility and be turned into energy. But it's $50 a dry ton just to get it to roadside. Another technology that we've looked at, and this is a picture from the west, but this has also been used in the south, in Texas, and some places like that, where they might be doing some understory or invasive species kinds of controls, what they call terrain chipping. And so this machine is a Pecon mobile chipper. It's mounted on a four-wheel forwarder, and it picks the stuff up, runs it through the chipper, puts it in the trailer, takes it out to roadside. Costs pretty high. I can't remember what that number was, but I just flipped by it, and I can't go the page up. All right. So another version, this was just last week out in Utah. We can put it on a forwarder. We can go around and we collect all these bushy things and pick them up, put them on a forwarder, take them out to roadside, forwarding it to roadside, putting it through the chipper. We're thinking we can do that for about $50 a dry ton with this kind of system. It's a forwarder, big loads of wood, takes it out to a chipper or grinder at roadside, that $13 a dry ton kind of chipping grinding cost. We can get it in a truck for $50 a dry ton. But it's not hauled anywhere, and it's still above the target that we're looking for. Another system that's being envisioned for the southern United States is the application of short rotation woody crops. And we actually have a project going in Arkansas and another project going in Kentucky to plant poplars and harvest them after 3 to 5 years and use those as feedstock for power plants. As we're working through all the calculations associated with this particular system, this is Case New Holland forage harvester that's got a modified head on it specifically for harvesting small diameter wood. Runs it through the machine, runs it through the regular forage chopper, and blows it over into the trailer to get it out to roadside, and then the tractors and trailers are shuttling this back and forth to the roadside. DOE is actually funding development of this machine to expand its capability to take larger, heavier material, do it in a productive way. Their specification would be to go up to 6-inch diameter trees through that chipping head at a reasonable production rate. Willow is really short. It's like 2-3 years. And with poplar, we're thinking it's going to be a little bit longer in an energy context. The poplar that we're growing right now is going for pulp fiber, so they're going at even 10, 12 year kind of rotation on poplar for pulp application. But in the energy context, the model that is being discussed for Arkansas and for Kentucky would be that shorter kind of rotation, 3 to 5. But used with a machine like this kind of a system could put stuff at roadside in truck for $18 a dry ton. Pretty reasonable cost considering. They're looking at about 15 tons per acre at a 3-year rotation. Depends, on-site productivity, et cetera, and is this a fertigated kind of site? Does not exactly. Where stumpage price is really going to be high is in short rotation. You're right. So the harvesting side of it, we might be able to do at a reasonable sort of price with that kind of technology if it all works. Stumpage price very high, still prices it out of the DOE or puts it very high in the DOE target. So the technical question, the thing that our unit gets focused on is can we do it? Is there a technical solution out there that can harvest small trees, chip them up, make them into something that the energy market would be willing to buy, clean enough, dry enough, whatever it is that they want to have, small enough pieces? Yes, we can. We have machines that can do everything, that can chop up anything out there. Can we do it for the price? Not sure about that. Price is still an issue, and so what we have, if we look at this, can we use wood for energy at the prices the DOE is working on? This first one, the efficient systems challenge, is significant. We've got to be able to get the price down. We're going to have to head towards things like that high production feller buncher system operating in pines in the south is more likely to hit the DOE targets than any of these other kinds of systems, collecting forest residues, baling things, etc. Perhaps the short rotation woody crop hardwood model will work, although stumpage price is a concern. Depends on the cultural practices that are going to be employed. The market demand is going to push us towards those kinds of purpose-grown wood sources. The stuff that we're collecting, that's the junk, the wood waste, the logging residues, etc., are going to be pretty pricey sorts of things, but they may represent opportunities for us to do things in forest management for forest management purposes. If there was a market out there for energy, you could say, I need to take stuff off the landscape to achieve my fuel reduction goals and move that wood into that market. So technically, we're working towards solutions, but it's still a challenge. The efficient systems are the ones that are going to have to be developed. But then we have this other question which comes up as we're developing this market for woody biomass, and people are looking at this total demand of all this material that could be moving to these energy markets, scares them to death. We have to address this issue of, even though we can do it, should we use wood for energy? And I would make a point here that Kermit versus the Lorax, the public is starting to weigh in on this whole issue of woody biomass. And this is actually from the UK, not biomass, but biomess. This is something the Simri Liberation Front or some kind of UK environmental organization climbed up the smokestack and hung their Welsh sign off the side. But the issues that the public sees, or the concerns that the public brings to this issue of wood for energy, one element is cutting trees is bad. The same things that we've faced with challenges to the social license for forestry, for other products, apply when we start cutting trees for energy. So it's the same kind of issue. I'm concerned that we're cutting my forests, we're cutting our nation's natural resource here to do things. Don't like that. Don't like to see the trees cut down. Don't like to see the mess behind. There's also public concern that focus around this issue of burning anything. So when you tell them that you're taking wood and you're going to a power plant with it and you're going to put it in the power plant and it's going to be burnt, then people have a vision of smoke. They have a vision of soot, the Industrial Revolution and air pollution and all those kinds of things come to the fore when you talk about burning things. So power plants that are going to be co-firing wood, going to be burning wood, are going to face public concern about air quality issues. Not so much when you say about I'm going to take it and turn it into liquid ether to liquid fuel, but if it's going to a power plant, burning, something there is bad. Another thing that's coming out with this whole question is what's called issues concerned about wasteful technology. People don't like things that waste stuff. And so if I take wood and I go to a power plant and co-firing and I throw the wood in the coal pile, the amount of energy that was in the tree that I get to recover and turn into electricity is about 20% of the energy that was in the tree. I lose 80% of the energy in the wood itself, inherent in the wood, in inefficiencies in large-scale coal plants. So people look at that and they're raising concern and they're saying, well, if I'm going to cut my forest down, great, but don't waste what's in there. Don't waste that resource in something that's 20% efficient. So waste is a bad thing. The public is also concerned about seeing the public. Another public concern is expressed around the idea of actively managed forest is less desirable than a more natural kinds of forest. We're getting this kind of concern when we talk about the Southern Forest Futures Project and that whole issue of the increase of pine plantations from 30% of the southern forest landscape to 60%, or no, 34 million acres to 67 million acres, 1%. 30-something million acres of pine plantation and doubling that to 60-something million acres of pine plantation, you get pushback from the public saying managed plantations, don't like those as much as we like the natural forest. Not sure we want to see that kind of a management activity on the landscape. We also have a lot of discussion from folks on concern about impact on existing uses. This plays in a couple of different ways. One is our forests are already being used to support lots of forest industry, and we'll hear the story that says we're going to trade jobs in a pulp mill that are worth $60,000 a year for jobs in a biorefinery that are fewer jobs and perhaps not as good paying jobs. Concern about the impact on those existing uses. Also concern about impact on the existing uses of the landscape. So whenever we talk about wood for energy, people get this issue of land use change brought in. Are we going to take pasture land and turn that into pine plantations or poplar plantations? The vision that's laid out in the billion-ton update says, where's all that energy crop going to come from? Well, we said we're going to use pasture land, marginal farmland is where those increases would come from. There would be a land use change, and people are concerned about that. You see that come out in legislation then. Under the Renewable Fuel Standard, the definition of what is allowable for renewable fuel is stuff that comes from land that was that way before, not from new landscape uses. So if it's pine plantation that was existing, was cleared prior to date, then that's an okay renewable biomass source. But if it's coming from land that was cleared after that, no, that wouldn't be acceptable as or considered a renewable source of biomass. We're trying to address those concerns, and the approach to address those concerns is let's get some science behind it. And so you see some reports like this that are focused on scientific issues of nutrient cycling, wildlife impacts, etc. Those are leading to the development of biomass harvesting guidelines where they'll specify if you're going to harvest this material for energy, then you've got to do X, Y, Z. And that X, Y, Z may cover a whole range of ecological impacts. It might include you got to leave coarse woody debris for the snails. You've got to leave 30% of the residual biomass behind for nutrient cycling purposes. You've got to leave this behind when you do these kinds of treatments to address erosion or wildlife or a whole range of issues. And those kinds of guidelines are going to constrain the way that we can manage if we're going to do biomass removal for energy. So as I pull all this together, we have this issue about are we going to cut wood for biomass for energy or not? We've got the technical question of can we do it? And we have significant challenges there in order to reduce the costs, in order to get the most efficient systems on that can produce it at the kinds of target costs that are going to be necessary to be able to make energy work from an economic perspective. We also have this issue about having to deal with the social concerns about the impacts, the changes, etc., that are going to happen if we start doing this in a big way. We look at all of the drivers, energy independence, environmental impacts. There's certainly going to be a role for wood for energy in the future. Southern forests are going to be one of the most significant places that's going to happen. The southern forest produces over half of the forest output in the United States already. So if we start using wood for energy in the United States, over half of that impact is going to be in our southern forests. Our technology is improving. There's a number of these projects that are working and trying to drive the costs down or try to find new ways to create higher valued products out the end of it. And that technology change is happening. People are making those sorts of changes. I'm confident that we're going to be able to find some solutions there. But this big question here at the bottom about the social license for our active forest management, we've discussed that with just the context of traditional forest management for several years. That whole question of the social license of how we manage our forests, what we use our forests for, is now going to be extended to this question of using that wood from the forest for for energy products.